This is a question on rate. There's a question on rate, and it said in a certain reaction, the rate determining reaction is A plus 2B given as C plus D. And now it says A, write an expression for the rate equation. B, deduce what will be the effect on the reaction rate by I, doubling the concentration of A, and II, doubling the concentration of B. And then C said, how should the concentration of B be changed in order to halve the reaction rate? And A said, write an expression for the rate equation. Now, the most important thing we have to check out is whether this reaction is a rate determining step, and that is stated in the question that the reaction given us is the rate determining step. So that is simple. We'll go ahead and write our rate equation. That will be, let's say A. So A, our R is going to give us our specific constant, rate constant, and then we have reactant A, then we have reactant B raised to the power 2. Now this is the order of reaction with respect to B, and the order of reaction with respect to A is 1, so you don't have anything at the top there, which means the moles of these reactants we know are equal to the order of their reactions, because it is the rate determining step. Now let's look at B. Now I says that we double the concentration of A. We double the concentration of A. But let's remember that when we double the concentration of a first order reactant, that is when we have a rate such as this, and then we increase the concentration of A by N. We increase the concentration of A by N such that we have our new rate, which is R1 to be equal to K into brackets NA to the other one. And then we can say that R1 is equal to NR. R1 is equal to NR. Okay. In this case, our N is equal to 2 because we are doubling the concentration of A. So when you write our rate equation this way, we have a constant, and then we have 2A. And then we can write our new rate, which is R1 again, to be equal to a constant, and then we have, okay, let's bring the 2 out, so we have A to the power 2. So how do we know that the rate will double? Let's divide the this R1 by the initial rate over here, by this initial rate which we have written as A. So we will now have our R1 divided by R. This will be equal to 2Ka bracket B squared, all divided by our K, and then we have our A in brackets, and B squared. So what is going to happen? We're going to have this cancel out this, as well as this cancel out this, and a K also cancelling out. So what is going to be left is R1 over R being equal to 2. Now we are looking for R1, so this means that our R, this implies that our R1 is equal to 2 times R. So how do we conclude this? We can now say that when we double the concentration of A, we'll have our rate of reaction to be double. That is going to be 2 times R. 2 times the initial rate of the reaction. Okay, now let's look at the II. This time we are doubling the concentration of B, but remember that B is a second order reactant, so let's see if we have R to be equal to K into brackets B square, and now we are doubling it to give us R1, and then we have K into brackets NB. We are increase the concentration by N to the power square. Now remember that the effect is going to be that we'll now have our R1 to become N square. That is the rule for a second order reactant. So we'll have N square, and then we have our constant, and then we have in our brackets B square. So this simply means that for a second order reactant, our new rate of reaction is going to be at N square the initial rate, N square or the initial rate. So let's look at what happened. Okay, so let's call it R2. Let's call it R2 when B is double. So when we take R2, we have our K, our A, then we have 2B square. So this is simplified as 2K. We have the square brackets of A and B square. And so what do we do then? Let's divide R2 by our initial rate, which is R. So this is going to be 2K, and then we have our A, B square, which is going to be divided by, okay, I just noticed something is wrong. So per this rule, if we have 2b to the power 2, per this rule, it means that we should have 4 times the rate over here. So let's see, this is going to be 4, which means this also is going to be 4. So let's divide by the rate, which is our K, A, B to the power 2. So again, we have this cancelling out, this cancel out, and this cancel out, which means our R2 divided by R is going to be equal to 4. So when we make R2 the subject, remember that's what we are finding, it's going to give us 4 times R. So when we double the concentration of B, which is a second order reactant, we are definitely going to multiply the rate of the reaction by 4. So to do that simply, you can just come here, we can come here straight and write our R2, and then in place of N we'll bring our 2, that is, we are doubling the second order reactant, so 2 to the power 2 times R. So we find out that our R2 is going to be equal to 4R. So that is it for the B. Now the C said, how should the concentration of B be changed in order to have the reaction rate? Okay, so let the concentration of B become B asterisk when it is double. B asterisk when it is double. So for the half rate, it is going to be 1/2 R, giving us KAB asterisk square. So because we are halving it, that means we are dividing the rate by 2. So this is what it will look like. It will look like when we divide it by 2. So what do we do? Let's divide this by our initial rate. So let's say 1 out of 2 r divided by our initial rate, and this is going to be our half rate divided by the initial rate. So let's see what can cancel out. We can cancel the constant. Our a is also going to cancel out, as well as the r. So this is going to give us 1 out of 2, which is going to be equal to our b asterisk b asterisk square divided by b square. So what if we multiply through by b square? It means we're going to have okay, let's bring it to the top here. So we're going to have 1 out of 2, and then we have b square, which is going to be equal to b asterisk square. Okay, so remember we are looking for b asterisk square, which is the concentration of B needed in order to halve the rate of the reaction. So because this is square root, let's take square root of both sides. So square root of half b square, which is going to give us the square root of b asterisk to the power 2. Now this is going to cancel out, so we now have b asterisk to be equal to the square root of 1 out of 2 b squared. So simply we'll say that our concentration, which is b asterisk, that is root of 1 out of 2, that's the root of b square, and remember this will cancel out, so we're gonna have b asterisk given us b, concentration of b, times the root of 1 out of 2. So this is the end of the video, and then we found out that to be able to halve the rate of the reaction, then we need to multiply the concentration of B times the root of half. If you like this video, don't forget to subscribe and hit the like button so that you get notified for our new tutorials. Thank you.